All right, we're rolling. Take out your notes, please. I want to talk a bit more. I'm going to give you some time to work today. Reminder, you have a new homework guide sheet. We went through the new pages. The first assignment is going to be 15A, which is going to be due tomorrow. So let me talk a little bit about fractional or rational equations. Now, a rational equation, rational is just, you could call it fractional. Just rational sounds better. But fractional, rational just means an equation with fractions in it. Those can get very exciting very quickly, or they can be pretty easy. First of all, can somebody refresh my memory from yesterday? What is a proportion? What's the definition of a proportion? Go. Right.
Two equal fractions.
Two equal fractions. For example, x over 5 equals 7 over 9. And we covered 3 different ways to solve that yesterday. You can multiply across or divide. You can multiply down or divide. Or you can cross multiply. Any of those should work. Usually one of them is easier than the others. Sometimes going across is annoying, going down is annoying. Then cross multiply is probably your best bet. Sometimes it's super easy to say, oh, you're multiplying by 3 going across. I'll go ahead and do it. Now, a rational equation, here's the basic structure. A over B is equal to C over D. That's a basic proportion. And there are a couple of nicknames I need to cover. The two numbers that are going downhill have a nickname. They're called extremes. A and D are what are called the extremes in that proportion. I'll show you a way to remember that in a second. But if you have a proportion, which always is 2 equal fractions, the ones going downhill are called extremes. The ones going uphill, now I'm assuming everybody's reading from left to right. If you're Hebrew, you can read from right to left, and then you
Wait, that's just what they do?
Go watch in Israel. What's that?
That's what they do?
What's it who do?
They read from...
Yes, they do.
Yeah, in Hebrew they read from right to left.
That's weird.
So if you see somebody who's supposedly reading a Hebrew Bible and they're reading from left to right, they're faking it. You don't read it like that. You read it from right to left.
Oh. What if they're like reading in a mirror? What if you're like... What if they're doing it like in a mirror?
That doesn't happen very often. The two numbers, back on track. The two numbers that are going uphill are called means. Means. My old high school math teacher, God rest his soul, gave us a way to remember this. He was saying, you know, when you watch a commercial, I don't know if you, do they still have commercials from Mountain Dew?
Yep.
I haven't had a TV for like 20 years, so I don't know. But it's true. But
you don't have a TV?
They're all the topic shift for now. But there are some that Mountain Dew was kind of famous for having some nutty person like jump out of a plane on a snowboard with a parachute or something like and the title was Be Extreme or something like that. And so the idea of extreme, I got associated with like falling out of planes. So the extreme is going downhill. That was the way I remembered it. Means, I just figured, actually this was my old high school math teacher said, well, it's mean to force people to run uphill. So
yeah, it is.
Uphill is mean, downhill is extreme. Does that make sense? So How do you do cross multiplication? How do you cross multiply? You multiply the means, and then you set it equal to when you multiply the extremes. Okay. Now, I'm going to go you. This is kind of fancy language for something you already know how to do. But if they ever talk about means, just remember they're going uphill. And if they're talking about extremes, you're going downhill. Okay. So later on, if you go further in math, these words start coming back. You remember the 3 words called mean, median, and mode?
Yeah.
Play with those. Anybody remember what mean? I was going to say what mean means, but that sounds stupid. What's the meaning of? Darn it. What's the definition of mean in mathematics? How do you do it?
Average.
Yeah, like how? What do you do
You
mathematically?
add them all and then you divide them by the number of things you added.
Correct. That's called, and I'm going to give you a little sneak peek. This is something you're not supposed to know. But when you add and divide by the number of elements, we often call that an average. That's actually not quite correct. There are 3 types of average, at least. Mean, median, mode. All 3 of those are averages. The first one is called the mean. And this is actually called the arithmetic mean. The arithmetic mean. The one that you know, that we've known for years, is called the arithmetic mean. That means there's something, they put the accent on the T, on that syllable. Arithmetic mean. If you say arithmetic, that's a noun. Arithmetic is the adjective. So it's what kind of mean? It's an arithmetic mean, when you add up and divide. This does mean that there are lots of other types of means. Some of them are more advanced. There's something called the geometric mean, which is stronger. Instead of adding and dividing a bunch of numbers, the geometric mean is you multiply them and then take the square root. It's a different type of average, if you will, and it's a little more, it has different uses than this. But both of them are averages. Okay? You don't have to remember that, but the word mean is going to be showing up a lot in weird spaces as you go on in math. So here's where the word originally came from. Means are the uphill numbers of a proportion, and extremes are the downhill numbers of a proportion. That's pretty much all the homework really needs you to do. Now,
Are we done?
Funny. Example. I would like you to solve. No, that was just to describe where the word mean might show up in the future. Solve the following. This is going to be a little different than what you've done before.
Please be quiet so I can focus.
I'm not talking.
Face front, please. Write this down. You notice something a little strange about this one?
There's 2 X's.
There are 2 different x's. Normally it's just one x, you do cross, multiply, or whatever, and you're done. This, trying to multiply across, or trying to multiply up and down, is pretty pointless. It doesn't work, because there are 2 things that are blank. X times something is 9, 4 times something is x. You gotta multiply by the same thing? I haven't the foggiest idea what they're talking about.
You multiply 4 and 9.
Well,
I
how do you,
actually don't know.
there are 3 methods of solving proportions. It says multiplying across, no luck. Multiplying down, no luck. What was the 3rd method? Cross multiplication.
Cross.
Some of you get. Somebody raise your hand if you know.
I know.
Walk this through.
X squared.
Good. Equals.
36.
Yeah.
And then
That
you
is
split it
actually
in
not
half.
hard to get. Kind of, sort of.
Square root.
Square roots. Bless you, Eric.
Good job.
Bless you, by the way.
Very good at it.
What's x?
It's a
If
number.
x squared is 36,
Oh, 6.
or,
Negative 6.
got it, x equals 6, x equals negative 6. Now, I want to check to see if both of those are correct. How do you check to see if your solution is right?
You go.
Isabel, how would you check to see if these are actually true?
10 minutes. Ready?
Like if you solve anything, you get x equals 12, and you say, gee, I wonder if I made an arithmetic mistake. How would you check? You could. In other words, here's the equation that it originally came from. How would I know that these actually, plug them back in, yeah. Let's try it. 4 over 6, let me know what that reduces to. 2/3?
2 over 3.
What is 6 over 9? Remember, x and x, they're the exact same number.
2
So-
over 3. Oh.
6 over 9 reduces to what?
2 over 3.
Did it work?
Yes.
Yes, it did. Try negative 6. What's 4 over negative 6?
2 over negative 3.
Or you could say negative 2/3.
Negative 2/3.
Now try negative 6 over 9.
Negative 2/3.
Does it work?
Yes.
Yes, you're done. There are 2 solutions on this, not just one.
Okay.
Does it make sense
Yes,
on that?
this makes sense.
Alrighty,
Draw the line.
that's looking decent. I'm going to throw one last curveball at you.
Always the one last one.
Oh, okay, no. I thought they were gonna do a brain teaser on you, but they're not
But
doing
they're
it yet.
being nice today.
Frequency.
Yeah, Brendan.
Hang on a second. How much did I actually do here? There's some really exciting problems in here, but I don't assign.
Wait, like exciting to us?
Yeah,
Or
well,
like exciting to
maybe.
you?
They're just long. They're exciting. I'll make it sound dumb.
Or maybe he thinks they're exciting.
Y'all know me
Like
too
Miss
well.
Heron used to watch TV and tune out all weekend.
Try this. 3 over x plus 2 is equal to, hang on a second. Actually, hold on a second.
Well, that is cool. What just magically appeared? Oh, Mr. Calkin, there's something wrong with the door in the music
Got
room.
it. I'm sorry to get that. Okay, face front. Write this down. 1 over x plus 2 equals x plus 1 over 2. I'd like you to solve. How? Again, this is a proportion. Fraction equals fraction. And there are 3 ways to solve proportions. Multiply across, multiply down, or cross multiply. What looks like would be the best
To
bet
cross
here? Just like go up, let's raise your hand and upward,
Right.
please. Maria, what do you think? Cross multiply. What would you get if you did that?
X squared
Mhm.
plus 2.
Close. I'm gonna write it just the way they have it. Does that make sense? This times this equals what? 2. Now do this. What method would you use? This is called the binomial, this is called the binomial. How do you multiply those?
Would you
Tag off. Dress. Foil. First, outer, inner, last. When you multiply binomial, the foil. Take over Jack. How do you foil these? What would you get? Now we spent a lot of time unfoiling. We're gonna refoil it. We're gonna multiply them in. So take the first from each, multiply it.
X squared.
Jack, please. X squared plus, keep going. And the outer. Yeah, 1x. And the inner. 2x. And then the last. 2.
2.
And then that's equal to 2. Any like terms?
Yes.
Go.
X and 2x.
Go for it.
Which
X
is
squared plus
3x.
3x plus 2 equals 2.
plus
Now.
2 equals 2.
How do you solve that?
I know.
We just did a whole, Mary, go. You could complete the square, that does work, by the way, that
I
always
know.
works. So does quadratic formula. Go,
You can do quadratic formula.
maybe. You have to do
Also,
something
you
first.
can get the answer to 0.
The only time you don't get the answer equal to 0 is if you're lucky enough to solve with algebra. Can we solve with algebra?
No.
No. Rosie, why not?
Because there's two kinds of X.
Right, two different species or kinds of x. X squared and regular x. Cannot solve with algebra. So if soon as you say, oh, algebra's not working, immediately get the answer to 0. How do you do that, Rob? Subtract 2, as long as you do it 2. What do you have so far? Ah. How do you solve that? Andy, take over.
Is this the one that's blank?
You could, that's called complete the square. That always works. It's complete the square and quadratic formula always work on quadratics, degree 2s. But there's one method that might be a little faster. Brendan,
You do the GCF
of what?
X.
This thing factors. There's a GCF of x, what's left behind?
Me?
Yeah, please.
X plus 3.
Good.
Thanks, Joe.
What do you do now? Keep going.
You divide by X.
Well, if x is 0, you're gonna kill everybody in the room.
Oh, yeah.
There is a property that comes galloping to your rescue.
0.
Mia Jackery.
Zero pod.
Should, I don't think you're gonna be Yeah.
I'm sorry.
Can you put like X equals 0?
Yep.
X equals
Exactly. It's called the zero product property. This one's already solved. How do you solve this one? Correct. You have two solutions. Look at the original problem. How do you prove that your solutions are correct?
You put it back. Oh, let me write it.
Dad, very good, thank you.
You put it back.
Put it back, one at a time. Everybody look up here. I've seen some people do this on a test. I want this to be the first year where nobody does this. Everybody focusing on this? This is an error. Please do not do this. You see there are two x's?
Yes, I do.
Please do not put one x here and the other x here.
Is that fair?
That will not work. You're
Okay.
testing them one at a time. If you're testing x equals 0, you put 0 here, 0 here. Does that make sense? Don't do both. Don't split the difference. So let's just try this. If x is equal to 0, what does that look like? Rosie, help take over. Try x equals 0 with this mess. What does it look like?
1 over 0. Wait, no, X plus 0. No, oh my gosh, 2.
1 over 2, correct.
I'm sorry.
0 plus 2, it's okay.
Rosie.
Equals,
Equals 1 over 2.
does that work?
Yes.
Yes. So x equals 0, affirmative. Mia Ugolini, take over. Try x equals -3. Plug that in here, here. Yes, equals, does that work? Yeah, what's 1 over -1? Yeah, what's -2 over 2? Got it. Just prove it works. Does that make sense?
Yeah.
Every once in a while you need to factor. Yes, ma'am. Do they usually factor like that? Oh, do they usually both work? Short answer, yes, they usually both work. The only time it doesn't is, can somebody tell me if there's a restriction here?
Yes.
Like what? Go.
0.
X cannot be what?
Oh, okay.
X cannot be -2,
Why not? If you 1 over
because you
0.
blow it up. Yeah, cannot divide by 0. The only time I know of where it fails, like one or both of these fail, is if they're restricted. Like if I had come up with x equals 0 and x equals -2, I would have had to throw this one away, because it's restricted, it would have blown things up. It's better to throw a problem away than to die. Yeah, of course.
How do you do the downhill thing?
Which one?
Where you multiply,
Oh, 1 times 2 was the 2, that's on the right hand side.
no, the other, not the cross multiply, but the one that you multiply like 1 times, how do you, x plus 2.
Well, the only two things I multiplied are this diagonal, 1 times 2, and that's here. And the other diagonal is x plus 2 times x plus 1.
No, but there's 3 ways of figuring that out.
Oh, okay. The other 2 ways, where you're trying to multiply it across or multiply down, yeah, I would not do those, because we have no idea. 1 times something is x plus 1. Well, you're multiplying by x plus 1, I guess. And you gotta multiply this by x plus 1 and equal 2. You can do it, it works, but,
Well, how do you do it in general? Like,
it would be an fraction. Oh. If you have like a really simple example, like
Yeah.
3 over 5 is equal to 12 over x. Here you say, hey, it's times 4. You just do the same thing on the bottom. So
Oh.
20.
That's simple.
Now going down would be annoying on this. Like 3 times something is 5. There is actually an answer, it's annoying. It's 5/3. So you'd have to do the exact same thing here. And you would actually get 20. If you put this over 1, it'd be 60 over 3, which is 20. Yeah, that was the old way. Does that kind of make sense?
I understand.
Any other questions? Let me double check and make sure the homework is not going to throw a curveball at you. Open your book please to page 710. I want to show you something. This, by the way, is, let me double check. I'm going to change the, wow. I didn't expect them to do that. First of all, look at problem number 6. We're on page 710. Books open. Problem number 6. It says solve the following equations. Check your answers. Check your answers means plug them in. But I do need to add one instruction. The book is assuming at this point you're just going to do this automatically. I just want to emphasize, I want to give you a reminder. Number 6, list restrictions.
Oh my goodness.
The book is just going to assume you're going to do that forever now. Every time you have a variable in the basement, the book is going to assume you're going to list restrictions. Again, you don't have to list them as part of your answer, but you do have to know if you get that as a solution, you have to know to throw it away. Otherwise, you're going to include an answer that's going to blow up the problem, which is bad. Okay, so for number 6, let's look at number 6, 6J. The restrictions on these are actually easier than the ones we did in previous years. What the heck? In previous months. We've been together for a long time. Yeah, I guess. But look at 6J. Can somebody tell me the restrictions? Go. Oh, X cannot be what? 4, and X cannot be -3. Correct. Question. Is there a restriction of X cannot be -2?
Oh, Jay, what are you looking at?
6J. Why not? It's not on the bottom. You do not restrict things on the top. The top is safe. The bottom you cannot divide by 0. Okay. Make sense? When you get to, did I give you number 7? Yes. Number 7 is a problem here. Look at number 7B. Number 7B. It says find the ratio in decimal form. I want to change that instruction. Find the ratio in fraction form. Just leave it as a fraction. It's easier on everybody. You can make a mixed number out of it, because they're eventually going to say what's happening to the ratio as you go up. So if you want to put them in mixed numbers for number 7B, feel free. I actually did when I did it. Does that make sense? Now, there's nothing wrong with you using a calculator to check your answer on this. Just be aware there's not a calculator allowed on the task for the next, so don't get used to it.
Are you sure you want to do
I'm
that to
totally
us?
positive. Yes.
Yeah, absolutely.
Everybody good? That is all I have for you. So you have the rest of the hour to do 1, 2A, and 4 through 8. It's on page 709, 710, about. You're welcome to break into groups. Keep the noise at a reasonable level. Stay focused. And I'll talk to you later. People watching at home, bye, Catherine. Talk to you later.